Hello, thanks for clicking. Welcome to another Nometry production. Today we're going to be talking about lines and angles, how lines create angles, and what kinds of angles we can name them. All right, so let's get started on what we could do here. Let's start with some things that we know about lines and maybe a couple of things that we don't. So there's almost all definitions here. You have to know all your definitions. So let's talk about some lines that you might know about. The first type is parallel lines. Parallel lines are lines that lie in the same plane and do not intersect. Right? So this line and this line that I just drew, they would be parallel. Okay, so if I called this, let's say, line L, and this is line M, then we would write L is parallel to M. You have to understand how to write your notation as well as how to read it. L is parallel to line M. All right. On my example here I have a box, and on the box we have line L and line M. They are sitting on the same plane on this face of the box, and they are considered parallel. We can also use these arrows here to represent that two lines are in fact parallel. Okay, so we could have done that up here as well. If I would have put those arrows there, then you would know automatically that these two lines are parallel to each other. All right, next, perpendicular. Perpendicular lines are lines that form 90-degree angles. Okay? Lines that make a right angle. All right, so if I have a line here, and then I draw a line here, like for example, line K and line M, and I put this small little box in here. Remember that box represents 90 degrees. That's a right angle. Lines K and M are perpendicular. So we could write K is perpendicular to M. The upside down T is the way we notate perpendicular. All right, and we can see some perpendicular lines here as well. K and L make a right angle, so they are in fact perpendicular. Okay, skew lines might be ones you've never seen before. Skew lines are lines that do not lie in the same plane and they don't intersect. So not only are they not in the same plane, they also don't meet. So if you take a look here, let's take a look on the box here. Here's line K across the bottom of that box, and here's line M across the other face of the box. These two lines would never meet. Okay? It might be easier to see with this line in the back here. See this side of the box back here, this side back there in the corner? That area will never meet this line that's over here. Okay, they just can't meet. It's impossible. All right, so they're not on the same plane and they don't intersect. Those are skew lines. Okay, and finally we have parallel planes. Parallel planes are exactly what you think it should be. Parallel means they don't intersect, right? So they're two planes that don't intersect. So for example, if you had a box and you talked about the top of the box and the bottom of the box, those two would be parallel planes. They don't meet, right? The top of the box and the bottom of the box, they never meet. Okay, they would be considered parallel planes. All right, so those are some types of lines and one type of plane that you've never seen before. Okay, now let's take a look. We're going to name a pair of parallel lines on this, all right, picture here. So parallel lines. Okay, well, look, here's some markings here. This line is marked with this line. They're both marked with that one single arrow there. So these are on the same plane and they don't intersect. So let's call this DF and GJ. They are two parallel lines. And there's another set. Do you see them right on the diagonal facing side of the box? We have DG and FJ. All right, you could have said those as well. FJ with a line hat and DG with a line hat. Okay, they're both parallel lines as well. All right, how about a pair of skew segments? Okay, so remember, skew segments never meet and they're not on the same plane. So let's say, how about we use EF? EF. Now we got to find another line that's not on the same plane as EF. So it can't be on the bottom of the box, or the bottom of this figure, or on this side of the figure. And it can't intersect. It can't meet EF. So it looks like that would be GH would be one option over here in the back corner. Okay, GH would work. Those are skew segments. Oh, skew segments. So we need segment hats, not line hats. Okay, we're using segment hats. They're segments. Segment hat. All right. So those are two skew segments. Perpendicular lines, two lines that form a right angle. All right, so we can see the box here. There's a couple of sets, EF and DE. DE, let's use our symbol, is perpendicular to EF. Or we could say GH and HJ. GH is perpendicular to HJ. And up here we could have done DF is parallel to GJ, right? They're parallel. We can use our symbols now. And then finally, two parallel planes. Two planes that will not meet. Let me erase a little bit of my figure here. Okay, so two parallel planes. Let's see, we have D, E, F, this little triangle plane here, and the one. How about the one in the back? It's like having the front side of something and the back side of something. They'll never meet. So plane DEF and plane GH. What letter is that? That's J, I think. J. Okay, those two planes would be parallel. All right, that's using our definitions. Okay. All right, now, next definition, a transversal. A transversal is a line that intersects two lines at different points. So let's set it up. We're going to draw two lines. There's one. There's two. And now I'm going to draw a transversal. The transversal is going to pass through these two lines. There it is. Okay. That's my transversal in red. All right. Now, what you can notice, hopefully, is you see the red line intersects both of the blue lines. When it does, the intersection between the red line and the blue lines, it forms angles at each intersection. Okay, hopefully you can see it forms 8 angles. I'm going to number them. 1, 2, 3, 4, 5, 6, 7, 8. These 8 angles are all related by different definitions. And that's what we're going to talk about here in just a second. How are they related to each other? All right? So that's the next set of definitions. These 8 angles are all related. Okay, the first set of angles are corresponding angles. So corresponding angles are angles that lie on the same side of the transversal and on the same side of the two lines. So let me show you. We're going to set up our picture. All right, and then we'll number the angles here. Let's do 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now if you look, here's your blue line. Here's your red line that cuts through it. It makes 4 angles. Then you have another blue line, a red line that goes through. That makes another 4 angles. The corresponding angles are the angles that are in the same location, okay, the same location on each one of the intersections. So for example, angle 1 is in the top left-hand corner between the blue line and that red line. But so is angle 5. if you look at this blue line and the red line, angle 5 is in the top left corner. They're corresponding. All right. Is there another pair? Yes, there are. So angle 2 is in the top right, and angle 6 is in the top right of the other intersecting pair. Then we have angle 3 is in the bottom left. Angle 7 is in the bottom left. Angle 4 is in the bottom right. Angle 8 is in the bottom right. There's 4 sets of corresponding angles on this picture. Okay? All right, those angles are corresponding. They're in the same location on their individual, based on their intersections. Top left, bottom left, top right, bottom right. Alternate interior angles are angles that lie on opposite sides of the transversal between the other two lines. So here are my two blue lines. Here is my transversal that goes through it. I'm going to label these angles again. Okay. I'm not sure if I'm being consistent from the last way I did or not. It's okay. It doesn't matter. All right. I can write it any way I want. Okay. Alternate interior angles are angles that lie on the opposite. Here's the transversal. They're on opposite side between the other two lines. So for example, here's my blue lines. See them? There are my two blue lines. Okay. Now, if I kind of like box in between the two lines, this would be your interior. That's your interior section in between the two lines, the blue lines. Now, the angles that lie on opposite sides of the transversal between the other two lines, the alternate interior angles, are angle 3 and angle 6. They're on opposite sides of the transversal, opposite locations of the transversal, okay, inside the two blue lines. So angle 3 and angle 6. There's another pair as well. Do you see them? Angle 4 and angle 5. One is in the right-hand interior, on the top right of the interior. One is in the top left or the bottom left of the interior. Okay? They're alternate interior angles. Opposite sides of the transversal in the opposite location. Now, let's talk about alternate exterior angles. Okay, we just did alternate interior. Let's try alternate exterior. Oops, let's go for red for that. All right, and then I'm going to label these angles up. 1, 2, 3, 4. So alternate exterior angles are angles that lie on the opposite sides of the transversal outside of the two lines. Okay, so earlier, in between the two lines, we called this region the interior. If you're outside of the interior, like you're over here, up here, you're outside of the blue lines, you're in the exterior. So the alternate exterior angles are on opposite sides of the transversal, the line that comes through, the red transversal, in opposite locations. So angle 1 is alternate exterior to angle 8. They have to both be in the exterior. Then angle 2 and angle 7. Okay, they're alternate exterior. 1 and 8, 2 and 7. All right, that's your definition. And then finally, we have same side interior angles. Same side interior angles. Okay, so we're talking first of all about the interior. We're going to be inside those two lines there, those two lines going in the same direction. Let's label these numbers up here. Okay, you're going to be inside there. So we're going to be, here's your interior in between the two lines going the same way. Same side interior angles are angles that lie on the same side of the transversal in the interior between the two lines going the same direction or between the two blue lines. So angle 3 and angle 5, they're same side interior. Angle 4 and angle 6, they're same side interior. All right? Those are all the different types of angles that you have to be able to recognize. Okay? Now, let's take a look at a picture. So here's a picture. Now, this picture doesn't quite look the same as the one we did earlier. Let's mark it here a little bit. So the two lines going the same way, they were always our blue lines. So let's draw them in blue. And then we also have in red the transversal. So here's my transversal going through. There it is. Okay. Now we have our angles labeled. Now, in between the two lines going the same direction, this might help some of you. This is my interior. And then outside of those two lines, that's my exterior. All right, but first, let's start with corresponding angles. Corresponding angles are just angles that are in the same location. So 1 and 3, top left, top left. There are 3 other sets, 2 and 4, 5 and 7 are both in the bottom left, and 6 and 8 are both in the bottom right. Alternate interior angles. Okay, now we're in the interior here. We're talking about angles 2, 3, 6, and 7. That's in my interior. Alternate interior, angle 2 and angle 7. Okay, diagonal from it, 2 and 7. You could also pick 6 and 3. All right. Same side interior, on the same side of the transversal line that goes through, 2 and 3. Or you could do 6 and 7. And then alternate exterior, we have 5 and 4. Or you could say 1 and 8. All right? And those are all the definitions you have to be able to recognize. And that's it. As always, thanks for clicking.